Hi everyone. Welcome to the first session of the series Artificial Intelligence Awareness. My name is Subhashish Chakravarti. As you all know me, I'm a solution architect. My area of expertise are Azure, Dynamics 365 Finance and Operations, and Power Platform. This entire series is going to roam around three principles. Just like today, we are going to work with an introduction, an overview of AI, machine learning, and deep learning, following which we will go to the difference between these two postulates and processes. And then I will try to explain what are the different mechanisms, different algorithms, different processes that are different kinds of mathematical equations that are involved with Azure, I mean AI altogether. And finally, I will keep on posting this series videos so as to give you more and more, insights of how you can leverage all these principles with context to Azure AI. Okay, so without wasting much of time, let's get deep. So this is the setting of the context. So when I'm setting the context, let me explain what artificial intelligence is all about. Artificial intelligence or AI, which is the widely known buzz of the day, is a concept that makes a machine to behave and work like the human. It is kind of letting the machine mimic whatever action a human being is doing. Machine learning is a subset of artificial intelligence that is more or less connected to computer softwares, whereby you are teaching a software to learn and understand and judge and conclude based on various kind of data that you are inputting it to. Finally, the deep learning. Deep learning is a subset of machine learning, once again, that mimics the structure of the human brain, popularly known as artificial neural network or ANN. Deep learning is widely used in medical prognosis. Say, for example, patients who are having probability of cancers, cancerous cells, how the cancerous cells, to what extent they have, they have mitigated, they have migrated, they have, how, what is the concept, what is the current conditions of the cancerous cells. You can understand and you can predict beforehand. You can create various kinds of customer care chatbots. You can also create self-driving cars, mechanisms to understand the traffic signals and to drive the car on its own. So it's a huge syllabus, whenever you are talking about artificial intelligence, machine learning, and deep learning. It's just not about a very small video session, but it involves a lot of experimentations and understanding and then making it to practice. With that, the next question that comes to mind is, what is the difference between machine learning and deep learning? So machine learning is basically, as I was saying, it's a kind of a mechanism that makes the machine to understand, interpret, and to come to conclusion of what is the prediction based on the various kinds of input data. So machine learning is based out of these kinds of algorithms, supervised machine learning, whereby you are creating algorithms that are reliant on accurately labeled data and oversight from a developer or programmer. The algorithm is fed data, which includes input and desired output defined by the developer. The system then learns from the relationship between the input and output, training data to build the model. The model maps input data to desired output and is trained until the model reaches a significant level of accuracy. Unsupervised machine learning is what? Unsupervised machine learning involves not directly controlled by a developer and will be trained on data sets and with no labels. Unsupervised machine learning algorithms are used to identify patterns, trends, or grouping in a data set where these elements are unknown. This type of machine learning can identify the relationship between data points and can be used to understand and predict the similar data. Semi-supervised machine learning, as its name suggests, is a mix and match of both supervised as well as unsupervised machine learning, and it combines elements of both types of machine learning algorithms as well as unsupervised machine learning algorithms. Reinforcement machine learning is basically a machine learning algorithm that involves trial and error. So again and again, I'm understanding, I'm inputting data to my machine and finding the kind of accuracy that it is achieving. So I am rewarding the machine learning by some kind of a reward point. Every time it is failing, I am giving a negative marks to it. And every time it is achieving something, I'm giving a target to it. And every time it is getting closer to the target, I'm rewarding it with some kind of a reward point. And as more and more it understands, it learns and goes towards the target, then it is achieving more and more reward points, and finally it reaches the destination. So machine learning algorithms could be divided into reinforcement machine learning, unsupervised machine learning, and semi-supervised or supervised machine learning. So supervised machine learnings could again be divided into clustering, association, and dimensionality deduction, which we will see in our next slides. And supervised machine learning is, however, based on classification and regression. Deep learning is, as the name suggests, like it goes to a mimicry of the human brain, the way the human brain behaves. And the human brains is all about actions, and then runs how some kind of an electrical signal is interpreted by one receptor and one propagator and a transmitter. The same way, the deep learning is also consisting of some kind of a structure which is known as artificial neural network, ANN, which is a very complex mesh of so many hidden layers and an input layer and an output layer, whereby it keeps on learning through the hidden layers, layer after layer, where one output of one layer is equal to the input of another layer, and it keeps on reiterating and until it comes to a satisfactory conclusion. In deeper context, deep learning algorithm is far complex than machine learning. It needs fewer levels of human intervention, and it almost behaves like a human behavior, instinctively learning from its own error. And deep learning, in many ways, it is referred as emergent behavior, whereby so from one layer, the machine, the system, the structure is learning and coming to conclusion and is going to the another layer. So it's kind of an emergent behavior, it learning from its own error and keep on understanding. So as an example, this is a typical structure of a deep learning artificial neural network structure, where I have an input layer and I have a number of hidden layers, whereby I have the outcomes of hidden layers getting as input to next layer. And finally, these layers of hidden layers work as some kind of a black box. We don't know what is going on and what is circulating inside. Finally, we are coming to a conclusion of the output layer. Machine learning algorithms. So machine learning algorithms could have regression algorithm, that is linear and logistic regression. Linear logistic regression is a classic example of jotting out the data points and finally coming to a conclusion, extrapolating the conclusions and finding out what is going to come next. Linear regression is an algorithm that provides a linear relationship between an independent variable and a dependent variable to predict the outcome of future events. Dependent variable. What is a dependent variable? It means something which is dependent on an independent variable. Suppose I am talking about a mathematical model where I am inputting the ROIs of an organization over the years. So in first year, the ROI was ROI 1. The second year, the ROI became ROI 2. The third year, the ROI became ROI 3. Like that, it keeps on plotting up. I want to find out what is going to be my profitability in 5 years down the line. So when this kind of a structure is presented, then my dependent variables and independent variables could be plotted on a graph, and I have a typical equation y equal to mx plus c, where m is equal to the gradient, x equal to the independent variable, and y is equal to the dependent variable, and c is some kind of a constant. And this variable, this equation can predict the outcome down the line. So this is more or less what is known as a linear regression. Whereas a logistic regression is a modeling probability of a discrete outcome given by an input variable. So say for example, this shows an exam results of a student who is studying for 2 hours, and it has been seen that the probability of passing the exam is nearly zero. a student who studies for 3 hours a day, he is also very having a very low probability of passing the exam. For a person who studies for 4 hours a day, he is also having a very low chances of passing the exam. Whereas a student who is studying 8 hours of studying a day, he's having a higher possibility of passing the exam. So this is what the dependent and independent variables look like, and then it's a supervised classification model where I am keeping on classifying between the dependent and independent variables and categorically finding out the results. So, what is the difference between logistic and linear regressions? So, logistic regressions are supervised classification model, and linear regression are supervised regression model. Once again, linear regression is the dependent variable you are predicting is continuous. Logistic regression is dependent variable you are predicting is categorical, either 1 or 0. So either like the previous example where I showed you whether the student can pass or fail, that is 1 or 0, making it suitable for calculating the probability of any event. Linear regression, we can predict integer numbers, whereas logistic regression, we predict binary values. Examples of linear regressions are stock price of an organization sometime down the line based on the input coefficients, whereas logistic regression is an acclimatizing a spam or non-spam from an unknown sender. Okay. Yes, the most important and widely talked about feature of any kind of machine learning algorithm is the decision trees. Decision trees are basically binary tree type of structures where I have decision nodes, I have leaf nodes, I have splitting, I have entropy, I have pruning. So machine learning algorithms for both classification as well as regression structures, I can use decision trees. Say, for example, this is a classic example of actually it is predicting whether how to prevent and understand the risks of a heart attack. So if it is based on a number of parameters, say for example, the age of the person, the weight of the person, is a smoker or non-smoker. So if based on this, we can keep on creating the leaf nodes. A leaf node is something where it does not split any further, whereas a tree stem or a tree stem is somewhere where it can be again split up into smaller subtrees. So this is an iteratively process again and again until it comes to a conclusion or one end. Entropy. Entropy is what? Entropy is the degree of disorderedness of a system. The more the entropy is, the less is the precision of data. More the entropy is, more is the disorganized data. More the entropy is, more is the difficult it becomes to come to a conclusion. Pruning is what? Pruning means if the data volume of a tree is very, very large, then we might need to split up. We might need to shed out a portion of the tree so as to make it simple and make it compact. Decision tree is based on iterative dictomizer or ID03 algorithm, and random forest is another type of decision trees which we will see in the next slide. It's a completely mathematical model that has entropy, data purity, and information gain to consider. Entropy and information gain are calculated based on data purity. If data purity is low, then information gain is also going to be low. Obviously, because data purity means that data is very, very pure, data is very, very focused, and data purity is low means high entropy and low on information gain. Based on this, there is a mathematical equation that finds out the statistical count of yes or no based on a number of data pointers as is shown by this yellow highlight. You have to keep on calculating for each and every attribute until you come to a conclusion to consider as the root node. You have to start from the highest value of the information gain considered as the root node. This is from where you are going to begin your calculation. Decision trees are the ones from where further branching and decision trees need to be done and is indicated by a circle or a square. Leaf nodes, as I mentioned, are the ones where the final decision is achieved and needs no further branching or further splitting. If trees goes unnecessarily large and out of control, then we need to cut the trees, preventing further growth. This is known as the pruning, as I was mentioning in the previous slide. Random forest. Well, random forest is basically an ensemble kind of a structure, which is basically developed by Leo Bryman and Adel Cutler, that combines the output of multiple decision trees to reach out to a single result. Its ease of use and flexibility have fueled its adoption, so that it handles classification and both classification as well as regression problems. Random forest, just as this example is showing. Suppose I have a bunch of mails that have come to me, which is having both spam and non-spam, that is ham. Okay, so first I'm taking the first 20 out of them, and I'm actually juggling between this data and finding out if based out of a decision tree, which is a spam or a non-spam. I'm categorizing them spam or a non-spam. Again, I'm putting them back to the basket of my mail, and again I'm taking 20 randomly. It could be repetitive data, or it could be something new, and then I'm again applying the decision trees and finding out the which is it a incoming mail, is it a spam or a non-spam. And then finally again I'm putting it back, and I'm again taking out randomly 20 out of them, 20 mails out of them, and I'm finding out is it a spam or a non-spam. Then finally, I'm doing a voting, a majority voting, like first, second, and third, and I'm finding out that eventually that majority is vote as spam. So this is an ensemble kind of a structure. Ensemble means what? Ensemble means multiple people are involved to take a decision count, just as the way you do on a voting. In contrast to one decision tree, we create multiple decision trees with the data and then create the outcome as a combination of the individual results. Final output is the one with the maximum voting, and it creates randomized decision trees from the above bootstrapped data. So much of today on the introduction of artificial intelligence, but just as I said, it's a huge tree, huge ocean of knowledge, concepts, and precognitions. We would be getting deep into the subsequent videos, where we are going to see how these concepts could be postulated and be adapted and applied on Azure AI services. Thank you, and subscribe to my channel for many such videos. Thank you.